So we are going to see the topic functional safety for off-road vehicle. Uh, Say for example, the off highway. When you say off-road vehicle, which is not running on the road most of the times, for heavy duty vehicles, which has been used for the mining activities or for the agriculture purpose. Okay, so those are coming under this category. Let us see how this functional safety is been applied for this off-road vehicle. So the scope of this functional safety is uh, to look for the absence of any unreasonable risk. Why the reason why it is needed is to analyze the system function that can malfunction, and also it will lead to the risk potential risks. This is the scope. The scope does not change between the automotive and also the off vehicle off road vehicle. The scope remains same, and this function safety is applicable for all these areas: automotive, railways, aerospace, medical devices, agriculture machines, construction machines, and power plants. So we have seen various aspects of the functional safety for automotive application, and the same is also been applicable for the off road as well. But what happens? There is some changes which we will see today, and the standard itself is a separate standard. We follow ISO 26262 for automobile. And for this application, we follow ISO 25119 for this agriculture application. We call AG is nothing but agriculture. Um, that's why it's called off-road vehicle. And here also you have the ASIL, what we have seen ASIL A, B, C, D, but here it is ASIL is been converted to AGPL, agriculture. Uh, uh, AG stands for agriculture. So we'll see that levels here. And this functional safety ISO 2511 is been applicable for the tractors and machinery, which is applicable for forestry and agriculture. This standard is published in the year 2010 and it got updated in the year 2018. And this is applicable to all the E&D components and even for the programmable electronic systems as well, PES systems as well. And it defines the objectives based on the risk. It is having the systematic approach, and the document is been uh, well documented such a way all the requirements are captured, like technical safety concept, technical safety requirement, functional safety concept, functional safety requirements, and the risk estimations. Okay, all these are been captured here. And you have the functional safety levels, where you start with part one with respect to the principles of design and development, then you go with the concept phase, and you have the V shape, right? That's what we have seen for ISO 262. Here also you have the V shape where you follow the cycle. You develop hardware development, software development, then you interface, then you go for a verification and validation, then you go for a production operation, then if required, you need to modify on need basis. So you have the principles of functional safety concept as defined by this standard. You have HARA and AGPLR level definition. HARA stands for hazard analysis and risk assessment. And you also have we'll see this AGPLR in a detailed way. And you have the system hardware and software design preventing the risk other than the quality management system. When product is out and the production, the rules to be followed are being defined in this standard. This is the safety of machinery. The standard is ISO 13849. It's a generic safety standard which is applicable for a wide range of machinery. It includes assessment of non-electronic components also, and it varies with it is having a part one and part two. Where the part one is dealing with safety related parts for the control system, and it also helps for defining the performance level, system level, and software related aspects. And part 2 is the one which is dealing with the validation requirements. And you also need to estimate the risk. Today we have seen various, yesterday or today we have seen various types of risks, right? SLA category, SLB, SLC, and SLD. So here you need to risk, you have to estimate the risk based on the error. So even we also have the FISA for earth moving machinery, where it is going to deal with hardware, software, and then different interfaces integration. And you have scope, in scope and out of scope for the standards like ISO 25119. It deals with END and PES. And the out of scope is for it is not going to deal with hydraulic and pneumatics. And considering this ISO 13849, it supports all kinds of technologies and wide range of machinery. And it out of scope for this ISO is safety functions or performance levels that are to be used in the particular case is not being considered here. And ISO 19014. These are all the different FISA standard, functional safety standards for the off-highway industry. And this standard deals with the hazards caused due to failures in control system, which is used for earth moving machineries, like even companies like Bharat Earth Movers, JCB. Okay, so they are dealing with the earth moving machines, but they are in a position to follow this standard in order to avoid the fault, failures, hazards, and the risks. And the out of scope for this ISO 19014 is that hazards due to non-safety related control system and from the equipment itself is not being considered, such as electric shock or fire. This is the life cycle that we follow, function safety life cycle, where we start with function safety management, then we define the system, then we analyze the risk, and we do the assessment, and we start with the safety concept, and then we go with the hardware design, software design, then we go for a safety verification validation, and we go for the safety audit assessment and product release activities and after production. We'll go with the various definitions involved in this FISO. The first definition is going to be the safety control system. It's called as SCS. It is the one where a system can fail in a way that it creates a hazard, which is safety control system. Say, for example, this SCS for a propulsion may be included as throttle or gear shift or start-stop technology, etc. We also have a term called UOO, which is nothing but unit of observation or system of interest, which is nothing but what is there in the scope, what is the main purpose of this electrical electronic components and programmable electronic system. And we have SEOCs test, like in the case of SOTIF, we have SEOC in the case of automotive. Similar to that, it also have the performance level, like machine performance called MPL. We also have a performance level for agriculture-based equipments. We call this as AGPL. And the other definitions remain same. We have seen the common cause failure, dependent failure, independent failures in automotive application. So here also it remains same. You also have the MTTF, mean time to failure. So here it is termed as mean time to dangerous failure. It is mentioned as MTTFD. We have seen the diagnostic coverage in the today morning session, where DC, higher the DC is always good, because we are going to detect the thing. But on the other side, higher DC will also call for higher ASIL. So ASIL D, if the DC percentage is higher, what happens? It is coming under ASIL D category. Okay. In that way, you can also categorize it. And functional safety management involves the safety culture, competence management, functional safety plan. So you need to select the supplier and monitor the supplier. That's what when you're going for any development, the supplier role is very much important with respect to it can be with respect to hardware or the software or interface or the integration activity. For example, when you're considering the ABS having the ECU with respect to the actuators and hydraulics, that it's also having the CAN communication. We're going an input as a power to ABS ECU, having the different requirements, system of interest, first requirement, second requirement, third requirement, fourth requirement. All these are an input to this ABS ECU, and it defines the boundaries, and also it interacts with the requirements, different requirements, and also the external interface as well. So in this ISO 25119, you're going to have AGPLR, agriculture performance level rating, performance level rating. For example, steering, if you have the steering in the wrong direction, or if you're propelling the vehicle when the vehicle is in neutral or braking is not intended, you're going to determine the risk involved in this scenario. You're going to form a cross-functional team where it comprises of hardware team, software team, system team, product testing team, where they are providing the valuable input to the HARA. And this AGPLR is a combination of severity of harm, probability of occurrence with respect to harm and controllability. So this is all about the category. So we have seen ABCD in the case of ISO 26262, but here in this ISO 25119, we have ABCDE. So totally 5 levels in addition to the quality management. So you see here S0 is nothing but severity with no injuries. S1 is the severity with light to moderate injuries. S2 is the severity where the survival is probable, and S3 is the severity where you have a severe disability. Okay. So the high AGPLR applicable for high S3 severity is going to be high. Okay. And exposure. So E0 exposure is nothing but the probability of occurrence. So the probability of occurrence is E0 when it is not likely, and the probability of occurrence is going to be E1 if it is rare event, and probability of occurrence is going to be sometimes if it is E2, and probability of occurrence is going to be E3 if it is often, and if the probability of occurrence is going to be frequent, it is called as E4. So that's how it is also been mentioned like this: S1 to S3, E2 to E1, E2, E3 to E4. Okay, it starts with E0 basically, and you have the controllability where you can control the unforeseen situation. If the controllable is CC, is coming under C0. If it is simply controllable, it is coming under C1. If it is mostly controllable, it is called C2, and if it is not controllable, then it is coming under C3. So it starts with C1, C2, C3. Now there are some examples. You can see here the AGPLR is quality management. You can see here, even if the controllability is on the higher side, even though if you are not able to control, and if you have even if the probability is rare event or not likely, okay, it doesn't matter. So even E0 or E1, and if the severity is going to be no injury, then this is coming under quality management category. S1, E2, C3 is A category. S2, E2, C3 is also B category. You can see here the C3 is on the higher side, even though if it is not controllable, still it can fall under QM or A or B or C and D. But what is important is what is the exposure level and also the severity. That is very much important. So, but even the exposure level is also going to be rare. But what happens? Sometimes can be frequent. Say, for example, in this category, you have the frequency is more E4, and also severity is also on the higher side. So it depends on the case to case. We are determining the PLR, so performance level rating. So you're also going to determine with the help of severity, yes, and you also have the frequency, right? If it is nothing but the probability, what I'm going to do is I'm going to put in terms of exposure where I'm going to have F1 and F2. Where F1 is nothing but a short export time, the failure is going to happen, or the probability of occurrence. F2 is the long exposure time. And you have the P1, which is nothing but P1, P2, where you have the possibility of limiting you have the possibility of limiting. P1 is the hazard is possible to get limited under specific condition. P2 is not likely to control that, um, to reduce that, I can say. And P is nothing but the possibility of avoiding hazard or limiting the harm. F is nothing but frequency and or exposure to hazard, and S is nothing but severity of injury. So these are the different vehicles which is coming under this category. Where MPL is nothing but machine performance level. It's a combination of severity of harm, exposure E, under the controllability of this situation. And is coming under part 5, which has the MPLR category or the machine category. These are some of the failures. Say, for example, articulated frame dampers is going to have this many machine functions like body up, body down, steering, slow stop, hold still, machine direction. Okay, and the use case can be traveling and loading or unloading. And the failure type can be uncommanded activation or failure to apply the load on demand. So again, we have the ratings. So again, you need to have a safety goal for this. What you need to find out what is the top level objective of the systems of interest. So every non-quality management situation should arrive the HARA, and you should have the failure modes. You need to have the safety goal. Say, for example, avoiding the loss of unintended function. Sorry, intended function. Avoiding the uncommanded activation of intended function, which, for example, steering or brake can be taken into account. So here also we have the function safety concept, which includes the FSR, and these function safety requirements are derived from this safety goal, which we know already. And this function safety concept is also incorporating some additional parameters like mean time to failure, and we also have the different hardware, software, DC diagnostic coverage requirements, and those things to be met here. And we have the different attributes like diagnostic coverage. DC can be low, medium, or high, or a mean time to dangerous failure can be low, medium, or high, and the software required can be first level software, second level, third level, or high level of software. So even similarly, the category of the hardware is also been considered in that aspects. And same, when I say technical safety, functional safety concept, you also have the technical safety concept, where you are considering the technical safety requirements, which includes the architecture of the system, considering the safety interface between the components during the safe state for the functional safety requirement. The hardware software safety requirements are being considered, which are derived from the technical safety concept. And you have the safety analysis method, where you're going to use the fault tree analysis. It's called FTA. And you also have the failure modes and effects analysis called FMEA, which may be used to identify the faults and their mitigation actions as well. You can see here the various interaction between the components, which involves external components, sensors, microcontroller outputs with respect to the power supply. These are various elements, and we can see how the interaction is going to happen. It is coming under technical safety concept. Okay. And we have hardware design key attributes as well, where it is having different category, and we are also going to apply the diagnostic coverage for that. And then meantime to failure is also we have seen, right? MT FD. So those things are also being taken into account here when you're going for the analysis. So okay, so with respect to the development, not only for hardware, even you also need to look into the software aspects. where we go for a software safety testing, integration testing, and component testing as well. So we have the software architecture, we have the software design, software coding, software verification, software test plan, similar to hardware, and we have to integrate this hardware along with software. And we also have the software safety requirements. What we have seen with respect to hardware or the overall safety goal, we also need to have the separate safety requirements for the software. Uh, you have the software architecture again. You have the different attributes of system hardware, different response time, and few examples like it involves at power up. You are going to read the sensor output to direct the voltage transition, and you are monitoring the analog digital control inputs to microcontroller to detect any error value. You can see the interaction how it has been applied here for decomposing the application. I was also telling you ASIL decomposition, where you can decompose the ASIL to the next level, higher level to the next level. Same is also been applicable here, but the only thing is that you need to apply the interaction between one parameter to the other parameters. So you can see here lot of parameters are there, like sensors, touchscreen, Wi-Fi, Bluetooth, LCD, LED, memory storage, where it is having the interaction with different applications, different um, and data, different sensors, different network. Okay, so you need to analyze what are all the major components involved with respect to your software. What are all the block diagram? You have to label the inputs. You have to label the outputs. You should identify the task involved in performing the operation. First level of task, you call this as a tier one, and then you should also understand and determine the concurrency levels and also the dependency, and you should identify the second tier task and then application for this, and you have some methods for applying this architecture design with respect to your software. You can use computer aided tools. You can go for informal method or semi-informal method or formal methods. You can also go for a recommendation where you can go for through walkthrough or inspection. You also have the time triggered architecture for developing the software design. You also have the cyclic behavior for the architecture design of the software. You should always look for some traceability between the system and the software safety requirements. And you also have the software component design and coding. So we also know that we need to have the coding for generating the uh, readable version. We should also have the testable version and the maintainable version for the codes, models that we are going to design with respect to the software system. And then once you develop the architecture design, you are going to integrate the software and you are going to test the software. Okay, we have a lot of performance testing for the software. We have the functional testing. You can also have the black box testing as well. And you need to use hardware in loops, software in loops. These are the various testing methods. Even you can go for a vehicle testing. You can go for a different testing like ECU, VCU, TCU, whatever you call. You can go, but for this application of this agriculture machineries, you go with the ECU test. And there are some examples of a software FISA concept where you have the partition between first task to the second task, and you also need to have some memory related thing. Suppose if in case what can go wrong with the software, there can be some memory corruption or some wrong communication or the execution time can be higher, or if you are selecting the wrong processor, it can also affect the software system. uh, Even the redundancy may not be there, so this calls for a change. So all this to be taken here as well when you're going for the functional safety. And which data you have to use, which selection of the database is very important, considering the different microcontroller for the different range. And these are some of the key terms used in software FISA for the machinery, agriculture equipments or off-highway, off-road vehicles. You go with some application software or embedded software, or you go with some of the limited variability language software or full variability language software. So there are some examples: C, C++, or full variability language. When you're going for some of the PLC, it is a limited variability language. And again, these are all the step-by-step approach. First, you start with HARA, next the function safety plan, PNV plan, safety requirement plan, which involves safety should be with respect to function, technical, hardware, and software. Finally, you go for a safety analysis technique, and you are going to have some safety test cases. Finally, you're going for the functional safety audit. This is the assessment of the FISA, where you're going to judge the functional safety requirements, which can be assessed by the auditors to ensure that functional safety is achieved by a system of interest through reviews, safety audits, and safety assessment. And you can also ensure that all the activities and documents for the functional safety lifecycle have been completed as per the requirements. And you have the organizational unit, which is responsible for the functional safety of the machines carried out for the assessment of the functional safety. And lastly, you have the plan for assessment of the functional safety activities, which should be the part of the project functional safety.